Let's have a look at a typical example which is used quite often nowadays in marketing. This is called churn analysis. So a churn means you have a customer, but maybe he will not prolong his contract and leave and go to a competitor. So for example, in the telecom industry, this churn analysis is used quite heavily because you typically have a contract for 2 years and it's very expensive to get a new customer, and it's cheaper to keep the old customers. But some are maybe going to move. So the question is for the telecom company, who are the candidates which will move, which will churn in the near future? Because then you can make a good offer and try to keep them. It's easier, it's less expensive than trying to get new customers. So what kind of data do we have? And we have historical data. Actually, that's what we have in this table. And sorry, some kind of headings are in German, but it doesn't matter really. So what you can see is in each of these lines, you have one customer. And for each of these customers, you have recorded historical values. For example, you see the sex, Geschlecht. You see what kind of, how these things, how they got their contract, how long are they customers, 1 month, 34 months, etc. If they use fiber, false, true. If they had contact with the support, and so on and so on. Each of these values is called a dimension. And finally, at the very end, you have the historic information, who of these customers churned. So you see some false, they are still customers, others are true. Yeah, so these have churned and taken another contract by another company. And the question is, what do all the true ones have in common if you look at these other variables? And now you could try to find rules. This would be the classical approach. And you will find out it's not really clear. You cannot say something if somebody is male and is for more than 10 months a customer. These rules are too easy. So these are not complex enough, and they are hard to find, by the way. So what you're doing is something different. You basically give tons of data, thousands of customers into a system, and then the system tries to find out patterns in a multidimensional room. So here we would have all these columns are dimensions. You would first have a look which are not used. So ID is probably not of any value because it's just an artificial number. All the other ones are of use. And the final, this churn, is what it's called the goal vector. But all the others, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These 10 dimensions form a 10-dimensional room. Each of these customer is one certain point in this 10-dimensional room, and now you try to find patterns within this in this room which describe who is going to churn, who is not going to churn. And there are different approaches to this. For example, vector support machine, decision tree, k nearest neighbor, and so on and so on. And then you simply try out which work best. And the question always is the result finally satisfying? And this very much depends on the scenario you're in. So when it comes, for example, to medicine, and you would like to find out if somebody's got a tumor or not, then a probability of 70-80% would probably not be good enough. However, if you talk about churn analysis, then if you have a 80-90% probability that your prognosis is true is really, really helpful, because then you can attract all these people who are prognosed to churn, and you will probably get 90% of those, and you can make them an offer.